Okay, multiplying radicals and rationalizing the denominator. Let's start with multiplying radicals, and we are going to do monomial times a binomial. So something like 3 root 2 times 2 root 5 minus 4 root 3. So 3 times 2 is 6. So we're going to use the distributive law here. I'm going to multiply this times this, and then this times this, giving us two products. So 3 times 2 is 6. Root 2 times 5 under the radical sign is 10. Minus 3 times 4 is 12. And under the radical sign, we get 2 times 3, root 6. And that's all you can do. We don't have like radicals. We can't add or subtract these. And nor can anything be simplified. Root 10, there are no perfect squares that go into it, nor are there any that go into root 6. So this is a multiplying of a monomial times a binomial radical. What if we want to multiply together two binomials? So for example, let's do root 2 minus 3 root 5 times root 2 plus 2 root 5. And now there's some interesting things that are going to happen here. So for example, root 2 times root 2, I don't want you to think of this as root 4. I just want you to think of it as I am squaring a square root. When you multiply a root by itself, you get the number. So root 2 times root 2 is 2. Here we get, there's a 1, implied 1. 1 times 2 is 2, so we'll get plus 2 root 10. Here we'll get minus 3 root 10. And when we multiply binomials, we're using FOIL. And here we get minus 3 times 2 is 6. Root 5 times root 5 is 30. Okay, so don't think of this as root 25. Go negative 3 times 2 is minus 6. And root 5 times root 5 is 5, and 6 times 5 is 30. And now we can collect the terms. We have like terms. We have 2 minus 30. Let's lead with the number, which will be negative 28 minus root 10. Okay, so binomial times binomial. We could end up with four products, none of which collect together, right? Especially if, we didn't have any like radicals here. But we do have some like radicals, so let's keep that in mind as we're looking at this. And again, let's just say when we multiply root 2 times root 2, we will mentally just think of that as a 2. Okay, let's kick up a little further notch here. And let's give a more complicated expression. Let's say we had 3 root 2 minus 2 root 3 times 2 root 2 plus 3 root 3 minus 3 root 2 plus 2 root 3 all squared. Okay, so what are we going to do with this? We're going to multiply these two binomials together, and from that we're going to subtract the square of this binomial. Alright, so let's see what we're going to do here. That's equal to, okay, 3 times 2 is 6. Root 2 times root 2 is 2, and 6 times 2 is 12. 3, this will give me 9 root 6 minus 4 root 6. 9 root 6 minus 4 root 6 is plus 5 root 6. Minus 2 times 3 is 6, and root 3 times root 3 is 3, and 6 times 3 is 18, so minus 18. minus, now I'm going to write down a set of brackets because I have to subtract the product of squaring this. Now remember, when we square a binomial, you're going to get three terms, right? We're going to square the first term. So 3 root 2 times 3 root 2 is 9 times 2, which is 18. We then take the product of the two terms, which is 6 root 6, and we double it to get 12 root 6. And then we square the last term. 2 times 2 is 4, times 3 is 12. Okay, so we have 18 plus 12 root 6 plus 12. If you need to, you can just write this out. Just remember, what does it look like? It's 3 root 2 plus 2 root 3 times 3 root 2 plus 2 root 3. Right, and that's where we get 3 times 3 is 9. Root 2 times root 2 is 2. That gives us the 18. Plus 6 root 6 plus another 6 root 6, which is the 12 root 6. And 2 times 2 is 4 times 3 gives me 12. Okay, let's simplify this down. 12 minus 18 is negative 6 plus 5 root 6 minus, okay, what do we got in here? We have 18 plus 12. 18 plus 12 is 30, so it'll be minus 30, right? 18 plus 12, I'm in these brackets, is 30, and then the minus sign. And then we've got minus, and then the 12 root 6. So minus 12 root 6. Collect, we get negative 36 minus 7 root 6. So this is a much more complicated expression. It's multiplying two binomials together and then subtracting. And really, this is multiplying two binomials, but it's simply the square of a binomial. Okay, remember what that means. And you can, shortcut the squaring, right? You square the first term. And, remember, when we're squaring radicals, we have tricks, right? 3 times 3 is 9. Root 2 times root 2 is 2. 9 times 2 is 18. Multiply the two together. 6 root 6, double it. 12 root 6. Plus, whether that's a plus or minus, this sign affects this. This sign will be the same as this. The last term is always a plus. If that's a minus, it would be a negative times a negative. 2 times 2 is 4. Root 3 times root 3 is 3. And 4 times 3 is 12. Okay, and then, we're just simplifying down. And you can see what's going on here. Or pause and take a look at it, or ask questions about it in class if you have any questions. So that is our multiplying. Monomial times binomial and binomial times binomial. Next up is rationalizing the denominator. So I'm just going to clear things out. We'll come back and rationalize the denominator. If we ever get an expression where there's a radical in the denominator, we need to change it. We need to do that by a process called rationalizing the denominator. Change this into a rational number. To do that, we're going to multiply it by root 2, right? Because root 2 times root 2 is 2. But you can't just multiply the bottom by root 2, so we also multiply the top by root 2. Now, root 2 over root 2 is just 1. So what we're doing really is simply multiplying by 1. When multiplying fractions, we multiply the numerators together. 1 times root 2 is root 2. And root 2 times root 2 is 2. Now, if you check, you'll find out that if you go into your calculator and type 1 divided by root 2, and type root 2 divided by 2, you will get the same decimal expansion for both of those. Okay, let's just do one more. What if I had something like 4 root 3 over root 2? And I want to rationalize the denominator. Again, what we do is we multiply. We say I've got a root 2 in the bottom. I must multiply that by root 2 to get rid of the radical sign. And I've got to do this by root 2 over root 2, so I'm just multiplying by 1. I won't actually change its value. And up top, we'll get 4 root 6, and on the bottom, we'll get 2, root 2 times root 2. Oh, and look, 4 goes into 2 twice, and we end up with 2 root 6. If you want to check that, you can type 4 root 3 divided by root 2 into your calculator, calculate that, and calculate 2 times root 6 as well, and you should see that you get the same decimal equivalent. All right, what if? What if the denominator is more complicated? So let's say we have an expression like root 3 minus root 2 over 2 root 3 plus 3 root 2. Certain symmetry to that, right? 2 and a 3 and a 3 and a 2. How do we rationalize that denominator? Well, there's a special thing that we do. And if you think back to difference of squares, it'll make sense why we do what we do. Well, what we do is we multiply by the conjugate of the denominator. So the conjugate of a binomial is the exact same terms, 2 root 3, but it has the opposite sign. So instead of a plus, we put a minus, and we have 3 root 2. Now, if I'm multiplying by this, multiplying the denominator, then I must also multiply the numerator by the exact same thing. Get eraser. Right, I must also multiply by 2 root 3 minus 3 root 2. This whole entire expression evaluates to 1. So all we're doing is multiplying by 1. So we won't actually change the value of this, but we will change its form, and we'll get rid of any radicals. It's called rationalizing the denominator because it changes a radical into a rational number. Well, how does this work? How do you change this into a rational? Well, think about it. What I really have set up here is a difference of squares, right? I have a plus b times a minus b, which gives me a squared minus b squared. Now, before we go any further, let's put brackets around, or parentheses really, around each of the binomials. Because when we multiply the top together, we will have to FOIL. Same thing on the bottom, we'll be foiling it out. Okay, and let's use our scale. So I'm going to use FOIL. Root 3 times 2 root 3. Okay, there's a 1 in front. 1 times 2 is 2. Root 3 times root 3 is 3, and 2 times 3 is 6. I'm going to get minus 3 root 6 minus another 2 root 6. So minus 3 minus 2 will give me minus 5 root 6. If you don't see where that came from, it's simply the outer product. Root 3 times negative 3 root 2 is minus 3 root 6, minus, and then the inner product, 1 root 2 times 2 root 3 is 2 root 6, and it's also minus. And last we have minus times minus. The numbers multiplied together are 3. The radicals multiplied together are 2. Since it's 2 minuses, this will be plus 6. So our top expression simplifies to 6 minus 5 root 6 plus 6. Now let's do the bottom. This is a difference of squares. So 2 times 2 is 4. Root 3 times root 3 is 3. 4 times 3 is 12. Now watch what happens. When I multiply the outer, 2 root 3 times minus 3 root 2, I get minus 6 root 6. When I multiply the inner, I get plus 6 root 6. That's the reason we multiply by what's called the conjugate, the same two terms, right? It gives us that idea of a difference of squares. So the simple way really is simply to square this. 2 times 2 is 4. Root 3 times root 3 is 3. 4 times 3 is 12. Minus, it's a difference. 3 times 3 is 9. Root 2 times root 2 is 2. 9 times 2 is 18. So here's our next step. And you notice we now have a rational number, right? We just have 12 minus 18, which will be negative 6. Okay, collecting terms. We have 6 plus 6 is 12, minus 5 root 6, and on the bottom we have negative 6. Okay. Now, sometimes some people don't like writing a negative on the bottom. We could take that negative, or we could think about this. So, you may leave it in this form. Some people would multiply by -1 over -1. That changes these signs. So I'm just going to reverse this and write it as 5 root 6. That now becomes positive. Minus 12. The 12 becomes negative. And -6 times -1 is 6. And why might you want to pay attention to this? Because maybe this is the answer you get, and maybe in the multiple choice answers, this is the answer that you'll see. And you have to realize that these two expressions, this one here and this one here, are equivalent expressions. Okay, so if you simplify, if you're doing this type of a question and you're looking for this answer and you don't find it in multiple choice, then you may want to look for this one. Say, hey, this has a -6, this has a +6, and these signs are changed, and this is how something like that happens. Okay, shall we do one more? That's a fairly complicated one. A lot of the ones you'll start with will be much simpler. Let's just get some space down here. Well, lots of space. How about if we do something like 3 over root 5 plus 1. This is a much easier example, right? Start with the hard, then we'll do the easy. Okay, to rationalize, first of all, I have to realize this is a binomial denominator, and I multiply by what's called the conjugate, right? The exact same two terms, opposite sign, and in order to maintain equality, I'm really multiplying just by 1. Multiply the tops, okay? Again, I'm going to put some parentheses around here to remind me. So this is 3 root 5 minus 3. And what do we get here? Root 5 times root 5 is 5. Okay, we get minus root 5 plus root 5. This is always going to happen, right? We're always going to end up with like outer and inner terms, only they will be of opposite signs, so they cancel. So we get 5 minus 1. The easy way, seeing as you set this up this way, is simply to square this term and subtract the square of this term. And so this would be 3 root 5 minus 3 over 4. If this were over 3, if that was a 3 down there, then I could cancel. But if I want to do any cancellation, I need a number here, here, and here that the same number goes into. So if this, and this were all even, then I could divide out a 2, and maybe, as a matter of fact, I could divide out some other numbers as well. So you'll want to do the practice on multiplying radicals, monomial times binomial, and binomial times binomial, and also on rationalizing the denominator and being aware of how we rationalize a binomial denominator, and that is multiplied by the conjugate, which is the same two terms with opposite signs. Okay, and you'll find some of this stuff on page 22 in your textbook. And that will allow you to, take a look at that, and your questions are on page 23. So this ends radicals, and we'll now look at exponent laws with variable bases in the next video.